Good morning, everyone joining us today for our special webinar on how to build enterprise-grade UI with open source Lighting Web Components. I'm Satya Sekhar, Senior Developer Evangelist from Salesforce. Today I'm joined with Aditya Nagtopalli, who is also my colleague and Senior Developer Evangelist at Salesforce. Hi, Aditya.
Hi, Satya. Hi, everyone.
Yep. How are you doing? You are ready?
I'm ready.
Thank you.
Get set, go.
Yeah. So with that, let's get into our favorite slide, a forward-looking statement. So during this webinar, we might be talking about few of the concepts or features which may not be generally available on the platform. So please make your purchase decisions based on what are generally available in your own discretion. We are available on social channels like Twitter, Facebook, LinkedIn, and YouTube. You can reach us on Facebook and LinkedIn as Salesforce Developers. You can also watch awesome webinars and other interesting topics which we have covered earlier in our webinars and other videos. So please feel free to go through our channel, Salesforce Developers channel, from where you can find more videos. And also keep it noted that we are recording this webinar and we'll be sharing the recording once we are done with the webinar, probably in a couple of days. During the webinar, you're all muted. So if you have any questions, you need not really wait until the webinar is done. You can post your questions in your GoToWebinar Q&A panel, which will be there on the right side of your screen, where you can post your questions, and then we'll be answering as many questions possible during the webinar, and we'll be answering most of the questions towards the end of the webinar, where we have a specific Q&A session. And if the questions are not answered, then you can always, you can better go log out of your session and then log in again. It fixes the issue most of the times. And if you see any of the lagging while you are watching the webinar, or if there is a pause in the video, even then you can just log out and log in. You'll be able to access the webinar. With that said, I'd like to hand it over to Aditya to take us through the agenda of today's webinar. Aditya, it's over to you.
Thanks, Satya. So today we are going to cover these three topics. We are going to spend the first like 10 to 15 minutes talking about what's new in web standards. So I'm sure most of you joining us today might already be knowing about what's new, but for the benefit of the larger audience, we are going to do a quick overview of new things in web standards. And after that, we are going to jump right into the what, why, and how of the Lightning Web Component Framework, which is why we are here today. And it's not going to be all slides. We are going to have very exciting demos every now and then in between the webinar.
Yeah, that's interesting. In fact, I'm looking forward for this demos where I can easily learn about Lightning Web Components open source framework. So Aditya, like when I was working in my early days on the complete front-end web stack, so it was really hard to learn the JavaScript stuff because there were a lot of different JavaScript frameworks. I was working on EXT.js and my life was really tough. So I heard there are some standards that have come up in the recent past. Can you let us know what are the changes that have come up and how it's going to be more interested and easy to develop on JavaScript framework?
Sure. So before we jump right into what's new, it's helpful to go back a few years and take a look at what the web stack was in 2014. That is 5 years ago. So back then, the web standards offered a basic foundation for you to build apps. So the foundation had many shortcomings. It was just a page rendering platform. It was not an application execution platform. And there were only standard elements that were available. You were not allowed to create custom elements. You were not allowed to create, the framework as such, the framework didn't support creation of modular components. So what happened as a result of that? There are different software vendors who have come across, and they have created things called as frameworks. So they tried to solve all of these problems that are preventing developers from building modern web applications by building these frameworks, which try to solve this problem basically. Now what happens is you have different software vendors and each of them came up with a different framework of their own. The problem with that is each framework tried to solve the same problem in a different way. That would mean if you developed a component using one framework, you couldn't easily use that component to work on a different framework. So your component was sort of bound to the framework it was built in. And not only that, if you come to a developer's point of view, if you learn one framework, you will have to again relearn a different framework. So your skills essentially are not transferable. So it's like you're learning a number of frameworks depending on the need. So that was the way it was in 2014. But since then, there have been a tremendous change. So the standards organization has woken up, and there has been an unprecedented level of innovation and standardization on the frameworks. And this is how the web stack looks today. And the primary reason for this are these standard organizations, that is W3C and TC39. So these have been at the forefront of this innovation, of which Salesforce also happens to be a member. Okay, so now what has happened is if you look at the 2019 web stack, the web standards has significantly increased. That is, what the browser is capable of doing is a lot more than what it was previously. So now what happens to the frameworks? The job of the frameworks becomes very simple. They only need to provide specialized services depending on what the framework wants to offer.
So it's interesting. So like I can see that the orange rectangle at the bottom is really big. That's the web standards, right, Aditya?
Right.
Yeah. And I see, like, I was hearing about this term a lot in the recent past, web components everywhere. So what are these web components all about?
Right. So web components have been a part of the standard, as you can see on the screen. But in order to really define what web components are, they are reusable elements whose functionality is encapsulated from the rest of your code. So this is a very high level statement that I'm giving, but we are going to look at a demo and see what really web components are. And when I say they are reusable elements whose functionality is encapsulated, so it's not just one technology that is responsible for this. So if you can see on the screen, there are three different technologies that are responsible for web components. The first one is custom elements. So you know about the standard elements that are there on the HTML5 standard. So you have div, p, h1, h2, h3, and so on and so forth. But now custom elements, what they allow you to do is they allow you to define your own tags. So let's say I want to define my own tag saying hello world. So I can do that. So that is the custom element standard. The next one is shadow DOM. So shadow DOM's main purpose is to encapsulate your code so that it is not influenced by external styles or scripts. And it actually creates a sub DOM in your main DOM. We are going to take a look at that as well. And finally, you have HTML templates. So this is where the power of web components comes in, where you can create reusable code snippets. So whatever is that you want to be reusable, you place it within a template tag, and you can reuse it anywhere you want. Now the template tag offers two benefits. One thing, it provides slots wherein your content inside can be dynamic. The second one is the templates, whatever content you put within the template tag is not rendered on the UI. You will have to explicitly read its content through JavaScript and then insert it into the DOM. So that gives you a lot more flexibility of when you want this component to be loaded and where you want it to be loaded.
That's awesome. So you mean to say we are using the custom, we'll be able to create the custom elements there, and we can use these custom elements, which will be like our web components, which can be embedded in a HTML page like any other standard elements, is it?
That is correct.
Okay. So what are the other benefits with this particular way of programming?
So these are all the benefits that you get with web components. The first and foremost, of course, is reusability, because you build one web component using some templates, and then you can reuse it anywhere you want. The next best part is interoperability. So I've been talking in the initial slides about how frameworks limit the implementation across different technologies, right? But since web components is a part of the web standard itself, so irrespective of whatever framework you're using, your web components can be used across. Because the browser is able to understand it, it doesn't really need anything in between to compile it. The next one is encapsulation. So here is where the shadow DOM power comes into effect, so that your code is encapsulated within your own web component. So the external code cannot like influence your code. We will take a look at how that works in a demo, don't get confused. The next one is extensibility. So the way web components works is whenever you're creating a custom element, you actually extend a standard element or an HTML element. So what this allows you to do is you can create like a base web component which consists of minimum functionality, and then you can create various web components that build on top of this. Okay, and finally, composability. Of course, web component in a component-based architecture, it's a building block. So in the end, when you want to build an app, you can build an app using various web components which can communicate with each other. So with the web component, you can expose public APIs that can be read by other components, and they can work seamlessly with each other.
Right. So with that, I can see that we can do a lot of modularity, and I can also see all the benefits that we can reap from any other object-oriented programming in general. Now we can do it from the JavaScript frameworks itself.
Correct. So now that you have mentioned about modularity, I want to quickly talk about the next standard that has come out. So this again is a part of the whole ECMAScript standardization scenario that was going on. So modules is all about reusability. So if you have a piece of JavaScript code that you want to reuse across different projects or different apps, you can actually export them into a bundle, which we call as a module, and then these modules can be imported in other files. So if you take a look at the example on the screen, so here I have two functions. One is calculating the diagonal, one is calculating the square of a given number. I'm exporting these functions using the export keyword from lib.js. And in main.js, I'm actually importing these two functions from lib. And then I'm able to use it within my code. So this is how you can create a lot of reusability between all of your code.
That sounds like a perfect plan of modularity, where you are creating the modules and then you are exporting it, and whenever you want to use that module, you can just use it there.
True. Yes.
Yep. That's great.
And the next feature that I want to talk about is decorators. So this is something that is not yet a part of the whole standard. It is in the phase 2 of proposal stage. The decorator concept as such is not something that is new. So in object-oriented programming language, you have the decorator pattern, where you can extend the functionality of a given object only of that particular object, not of a different object. So you can feel free to extend one object and not the other. So that is the very same concept in JavaScript as well. So here, if you can look at the screen, there is a function that tries to make something read-only. And I use it in a different place by prefixing it with @. So if you look at the class cat, I'm saying @read-only, and I have a function which is returning something. So now if I want to make this function read-only, I just need to denote it with @read-only. And if I have another function, and if I don't denote it with @read-only, that would still work the way it is supposed to. So decorator is essentially enhancing the behavior of a function without adding a lot of code to the function as such. So the functionality is different, defined in a different function, and you can place it wherever you want without changing the actual code of whatever you're changing.
Okay, so we only need to use the annotation there, where Correct. We are going to import the functionality as an interface, like in our current method, is it?
Correct. The terminology goes like this. So we call this a decorator, and we say we are decorating a given function. So that is how the terminology works, just so that you are not confused when I'm talking about it.
Got it. Pretty clear. At this point of time, I believe, Aditya, like if you can show me something in a demo, because I'm a developer, I always feel like if I can see something in demo, then I understand it in a better way.
True. Yeah, I've been talking a lot, so let's quickly go to a demo.
Okay.
So here is where is a simple HTML file that I built. Okay, I haven't built this using any framework. This is just using the web standards that I have built it. Okay, so here what I've done, I have created one some text on the screen that is built using a standard element. And now here I'm saying that this is the text that is built using a custom element. So to the end user, if you take a look, it is not any different. It is exactly the same. But where is the difference is in the code. If you take a look at the code for index.html, so here is the code. For the standard element, I have used a div tag. Now, when I say it is a custom element, here is where I have created hello world. Okay, so now this is not something that is a standard element, right?
Yeah, so I know HTML, head, right. Body, H1 is standard. Yes, hello world is custom.
Correct. Now, where have I defined this hello world is actually in the JavaScript file. So in the JavaScript file, this line number 7 is actually going to take care of saying, I want to define a new custom element. And here is the functionality of that element. And the functionality is defined in a class. So again, classes in JavaScript is again a part of the modern web standards, ECMAScript 6+. Okay, so just like any other object-oriented language, you define a class which extends the HTML element, and you can define whatever is the behavior of the element. So in this case, I'm saying whenever I put this tag, I want this to be printed on the screen. So it is as simple as that. What you'll also notice is that I have given a certain style. So I said the div is going to be of color red. So what is going to happen here is, irrespective of whether the div is a part of the standard specification or a custom specification, it is going to be colored in red. Okay, so now that is how a custom element works. So the next part is all about encapsulation. So I said, what if I don't want my component to be influenced? So let's say I have my own color scheme, and when some other user adds my component to their code, I don't want their styles to override my styles. So in that case, I use something called as a shadow DOM, and this is the output. You'll see that now whatever is my custom element is shown in black. Now, why has this happened? Is because if I take a look at my code, again, the HTML code for shadow DOM is not different. It is just your custom element that you're showing, nothing different at all. But when you come to JavaScript, you'll see that I have added one more line where I'm actually creating something called as attach shadow, creating a shadow root, and placing my content within the root. Now, how is it rendered in the UI? Is if I quickly do an inspect element, you can see that this is my custom tag, hello world, but inside that it is not just the div. We have something called as hash shadow root. So this is what helps you to encapsulate your content, which makes sure whatever styles you have added is within your custom element itself. So external styles will not be able to influence your code.
Okay, so basically when we render a HTML page, we know that HTML page is rendered as a DOM, and then if you are using your custom elements within your HTML page, so that subtree of the DOM itself will be like a shadow tree.
Correct. It's a bit complicated to understand. It is at the same time part of the DOM and not part of the DOM. So in the end, you're able to see it in the whole DOM tree, but then it is a subtree on its own.
Okay. So whatever styling, so you can just limit it to the boundary of that shadow.
Exactly.
DOM. Yeah.
Exactly. So that is what makes your components reusable across, because you know that your component is going to work the same way wherever you place it. Now, what you would have noticed is in all of the code that I have shown you, I have returned some HTML from the JavaScript page itself. Okay, but now here is where the power of templates is going to come in, where all of my reusable code, I need not put it in JavaScript. Okay, I can actually put it in HTML itself under this template tag that I have spoken about, and then I can reuse this. So like I mentioned, whatever is put within this template tag is not rendered on the UI by default. So what I'll have to do in my custom element specification, I will have to read the content. So I'm just using a simple document.getElement by ID. I'm reading the content of the template, and then I'm adding it to the shadow root. So this is how I'm picking up some HTML content and pushing it in.
Okay, so basically you're writing your components code within the template stack.
Correct.
And then you're adding it to the DOM using this particular call, is it?
Correct.
Okay.
So what you will also notice is I have something called as a slot over here. So if you look at my template, I'm saying it is hello world, welcome to the webinar. But what if I want the user to configure what should be the hello message? So I'm calling it as a slot by saying its name is greeting. So whenever I'm initializing my component, I can actually pass by saying for this particular slot, this is going to be my value.
Oh, so slot is a way where you can dynamically send the content while the page is getting rendered.
Correct, correct.
Okay.
So if you don't happen to send any content, it's going to take in the default value. So now since I'm sending the content of Trailblazers, the output is going to be hello Trailblazers, welcome to the webinar, which is what it is exactly showing. And you will see that I have also defined my own colors. I have defined a new button, all of which is separate from the remaining components. So
yeah, I can see that it's like different from what we have on the page as a whole. This looks like a separate component. Yeah.
Correct. So this is how the web standards has evolved over time. But you will notice that this is pretty basic. Okay, I'm actually writing a lot of boilerplate code. I'm actually creating a shadow, attaching it. I'm defining the template wherever I want to. So if I give it to any developer, they can develop their own way they want, and it becomes unmaintainable after some time. So that is where really the power of frameworks is going to come in, where it promotes standardization and it promotes maintainability, and frameworks add a lot of core functionality as well. At which time I want to now
Okay, that was a great demo, Aditya. So I really liked it, the way you have created a custom element using the HTML, general HTML. But we were talking a lot about the Lightning Web Components framework these days. So how is it different? Like, how can we build these custom elements using the Lightning Web Component framework?
Correct. So I've just before I was talking to you about the advantages of a framework, right?
Right.
So now what exactly is Lightning Web Components, or this is why we are in this webinar today. So Lightning Web Components is a brand new enterprise ready JavaScript framework created by Salesforce. Okay, and this is built on top of all the web standards that we have seen. So all of the concepts that I have told you about till now are being used in this framework. So it's not something that we have created as Salesforce. We have built this on top of the existing web standards. And what this does, it lets you create web components easily with very little boilerplate code. And also it provides a bunch of additional functionality, which we are going to talk through in the next couple of minutes.
Okay, so whatever you can do with the basic custom elements in the HTML, you can do it in much easy way by using Lightning Web Component framework. Correct. And we also get additional functionality along with it.
So to give you a gist of the additional functionality, the best one I can tell you right now is that whatever components that you build on the framework using the Lightning Web Component framework, they are also going to work on IE11. Okay, so we transpile the code down from ES6 plus code to ES5, and we add the required polyfills. So all of that is being done by the framework. So you need not worry about whether my component is compatible on a different browser or not.
That is really awesome, right? That makes many of the web developers' life easy. So again, we are sticking to the latest standards and making our component work in our previous version of the things. That's a great thing.
Correct. So now, to give you a little bit of history, this web component framework is something that we have introduced on the Salesforce platform a few months ago. But now what we have done is we have open sourced it. So what it means is that now you can use this framework to not just build apps on Salesforce, but you can build apps anywhere on any platform using a backend of your choice. So let's say if you're a Node.js developer and you want to use a Node backend, because in the end, the Lightning Web Component framework is a front-end framework, right? You're building web components, which is a front end. So if you want to use a backend of your choice, you can do that. And that is one of the benefits of the open sourced version of Lightning Web Components.
Oh, that's look great. So if I'm a Node.js developer or I'm a EXT.js developer or a React.js developer, so I can build Lightning Web Components or web components using the Lightning Web Component framework and then use it in my application, Node.js application?
Yes.
Oh, that sounds great.
So not just that, because we have open sourced, you're going to get all the benefits of an open source community. So we have hosted all of the frameworks code on GitHub. So you can go to the GitHub page, you can look at the code, how it is built, what are the nuts and bolts of the framework is what you can do and explore. And what this allows you to do is it allows you to learn the platform better. And the next part, of course, when you look at the code and you explore it, you also might find some issues. Okay, and you want to add some more functionality to it. So that is where we want you to go to the GitHub repo, work with it, and if you find any issues, raise it in the issues tab. And if you want to add some enhanced functionality to it, you can feel free to submit a PR to us, pull request.
Oh, so basically I can check out the code, I can use that framework, build my own component. Correct. If I build a new feature, then probably I can even contribute to the Lightning Web Component framework.
Exactly. So what this allows you to do is really two things. Okay, it allows you to be a part of our roadmap. So you can feel free to say, okay, this is a feature that is widely used and I want to submit it as a PR. So you automatically become a driving force for our roadmap and you are a contributor to our framework. And not just that, since Salesforce is a member of these standard organizations, we can take all the developer community's voice back to the standard organization and you not just influence our product, but you can influence the whole web component standard as such. So your contributions are going to be very valuable once you start working on open source.
That sounds great.
And I've already spoken about this, saying you can build on any platform, and because we have open sourced it, you can use any tool of your choice. So let's say you want to build using Webpack or you want to build using TypeScript, you can do that. And since we are writing a lot of JavaScript code, maybe you want to write unit tests for that code. So you can use the Jest framework for that. And in the end, when you want to deploy, you can deploy it onto AWS, Heroku, a tool of your choice. So with open source, we are opening it up for the community. You can actually look at what tools you're using, and you can continue using the same tools. We are not restricting you to anything.
Oh, that's the beauty of the open source community, right? So where we can build, we have a broader set of choices, and it is flexible. Wherever we want to build the application, we can build the application, and using a different tool, we can also test it and deploy it. That's great.
Okay, so you might be wondering why all of a sudden Salesforce has decided to open source things. It is not like the company, but no.
That was my question, Aditya.
Yeah.
You stole my question. Yeah.
But yeah, it is not the case. So Salesforce is very committed to open source. We use a lot of open source projects ourselves, and we also share our innovations with the broader open source community. So if you can look at the screen, open source has been a part of the Salesforce story since the very beginning. And all the audience, if you're interested to see what our contributions are, what our creations are, you can go to this website, opensource.salesforce.com, where you will be able to see the complete list of open source offerings. And like any other open source offering, you can contribute to it, and you can report issues as well.
Okay, so can we also reach out to these Git repositories of each, like you are showing Salesforce is contributing in so many open source stuff. So if I want to look into the source code there, that's the fundamental definition of open source, right?
Yeah, that is what is open source.
So can I get that source code right from this link, opensource.salesforce.com?
Yes, everything is very well documented. Mm-hmm. So what is this functionality about? Let's take Oak Cliff. We describe what is it about, and we have a link to the GitHub repo as well.
That sounds great. So that's great, Aditya. I saw the demo of HTML, custom element using the HTML stuff. It is really interesting. And you were talking a lot about Lightning Web Components framework, which makes the things really easy, and also we get more functionality out of it. So I cannot stop myself seeing a demo.
Yeah, I think I've shown you enough slides.
Yeah.
I think let's not look at any more slides from now. It's going to be all demos from now. So where are we going to start? So the best place to start is going to be the home page of any framework. So the home page for Lightning Web Components open source is lwc.dev. Easy to remember?
Yeah.
So here is where you have two sections. Okay, so the one on the left is kind of like a quick start. So without even jumping into the whole documentation, what if you want to quickly get your hands dirty? So you can run these 3 commands, and then you can get started with the project right away. Or if you want to dive deep and see what are the required installation steps, what is the documentation available, so all of the very detailed documentation, you can click on Get Started and look at it.
So that is a general developer instinct, right? So whatever we hear about, we want to try it first and see it working, then we believe, and then started digging deep into it.
Correct. So let's do just that. Okay, so what I'm going to do is I'm going to open the terminal, and I'm going to paste this command. So what this command does is essentially it runs this LWC create app tool. So now npx is a command that is used to, it is a package running tool. So you must be knowing about npm, which actually downloads the package and then runs it. But npx runs this package without downloading it. The advantage you get is whatever updates are made are automatically reflected without you having to run npm update and stuff. Okay, now the next one, LWC create app. It is actually a tool which is developed by our team, our evangelism team here. So the LWC create app is a tool that creates the basic project for you. So it gives you a quick start experience that it creates the required folder structures, it installs all the dependencies, and it also gives you a bunch of commands to work on.
Oh, that means I need not really worry about what are the different things I need to install in order to work on Lightning Web Component framework, and I can directly concentrate only on my stuff where I can write my business logic.
Correct. And LWC Create App again happens to be open source. This is the GitHub repo that I'm showing you. So other than having how to use it, it also has a bunch of other commands that you can run. So you can look at the detailed documentation of what commands are available, what are the parameters that are acceptable to those commands. And as usual, like any other open source thing, we welcome you to submit issues and pull requests to this.
Oh, I can see that there are commands for building the application, also running it, and also testing on the all of the
correct
features, right? Yeah.
So I have used npx LWC create app and I've given a project name for that. Now what happens in after I run that command is it actually asks me a bunch of different questions. So this is again needed because your code should be well documented. So what is your package name? For now, I'm going to go with all defaults. You give a description for your component, who is the author, what is the version number, and the license, MIT or whatnot. If you have a GitHub repo that you want to link this project to, you can do that. And here is what is interesting. So the package manager for this, you can choose between npm and yarn depending on what you're comfortable with, and then whether you want to register the web component or not. And finally, you can also decide whether you want to use an Express server configuration. So let's say you're not just building a front-end app, but using the web component framework, you also want to build some amount of Express.js configuration that runs in the backend as well. So if you select yes for this, it's also going to create the necessary Express libraries that you can work with. But for now, we are going to do it in a very simple way. So let's just go with no. And what it does is it creates a bunch of different files in the background. This is going to take a bit of time. So what I'm going to do is I'm going to show you the completed project. So this is how the folder structure is going to be the moment you install the app. Okay. Yeah. Now here, let's quickly look at the output. So how do you look at the output? Is you say npm run watch. So this is the command you run to actually compile your code and create a deployment server for this.
Okay, so with the previous set of commands, we have just created a configuration for our application. Correct. And it creates all the necessary folder structure for me. And then I can get into that folder structure and can start this command to run my application, is it?
Yes. So if you can see now, the run watch command has completed successfully. And now it has created a local server for listening. So what this means is your code is running locally. You need not deploy to any server to actually check the code.
Okay, is it a Node.js server which is running locally?
Yes.
Perfect.
So this is my application that is running. So we have created this code so that it is very easy for you to understand. But let me dive deep into what this code is all about. So the first and foremost thing, the advantage that you get with the watch command is what I'm going to show you. So here is the basic structure that I was talking about, right? So entry point into any application, let's take this application, it's listening to a server. The entry point is going to be in the SRC folder and it's going to be index.html.
Yeah, this is one common file I generally see when we develop for a web front end.
Any web technologies generally uses index.html and index.js to be the starting point, which is exactly the case here. Yeah. And what you'll notice is that it is all pure HTML content. We have defined a head, we have imported some styles, we have delivered a favorite icon. And in the body, all I'm doing is I'm putting one little tag. That is my app.
Oh, so now it's like it looks like any other standard element, but yeah, it's custom element.
It's a custom element. So the output that you have just seen, the lightning bolt symbol and the hello message, all of that is actually bundled within this app. Before we take a look at the app, I'll show you the advantage of the watch command. So let's say I want to make any changes and then I just click save. So the watch command is actually going to look for changes in my application and it is going to automatically reload the browser.
That sounds interesting.
So if you go to the browser, you are already seeing that I have made these changes of testing and it is already being shown. So I need not worry about saving my file, coming here, reloading the browser, worrying about caching issues and stuff. Whatever changes are made are reflected on here immediately. So that is why we are using the watch command. Okay, now let's see where my app is coming from. Okay, so now all of this is HTML, you agree, and this is a web component because I've shown you how web component looks. You can define your own custom tags. Now the place where all the web components reside is in the modules folder. So you go to the modules folder and what you see is there is one more child folder called mine. Now this is what we call as a namespace. Essentially, we use it to group similar functionality together. Okay, let's say you can do it in two ways. Let's say you have a bunch of functionality regarding the UI. So you create a folder called UI and you put in all the UI web components in that. And then let's say you create one more folder with some other name and you can put the other web components. So it helps you segregate it in that way. That is one way. Or the other way is because this folder is named mine, maybe I might want to think whatever components I created, I put it in my folder.
That sounds interesting.
Let's say Satya, you create some web components and give it to me to use in my project. Maybe I'll put them all under a different folder with the name of Satya.
Yeah.
So now this helps you to effectively segregate your components. And inside the my folder is where the actual web component is. Okay, so again, the web component, the folder structure is that you define a folder with the name of your web component, and that folder contains these files. So in this case, the name of my web component is app. So it contains app.html, app.js, and app.css.
Are these three the required files for creating any web component?
So technically, only the JavaScript file is required. And if you want to show some UI to that, HTML is required. CSS is only required when you want to add additional styles. So I would say JS is mandatory. Yeah. The other two things are optional depending on what functionality you're trying to build. But the important thing to note here is that the name of the files should be same as the name of the folder.
Wow.
So this is the naming convention that one must follow. And once you follow this, this is how you use the tag. So you've been looking at my-app all along.
Right.
So the way it works is it goes to the modules folder. It looks for the my folder. So my-app means my is the folder's name, that is the top level namespace, and hyphen app is the actual name of the component. So this is how it is built. And now all of this, like I said, if you run that npx command, it is kind of a quick start for you. All of this has come in. So I'm directly getting into how my component is built, what are the files that are created, and I can jump right in and modify code and view it live. Yeah, so that is what we really call quick start.
Right. So basically, when we run the create app command, there we have given the default name as my-app there.
Correct.
So it has created my app here, and it has created a folder called my, within which it has created a component called app, and it has given us 3 files to work with: HTML, JavaScript. Now we only need to concentrate on the business logic which we want to write in HTML and JavaScript. Is it?
Correct.
Perfect.
So now this is a quick start, right?
Yeah.
But if you want to really learn something, it's always helpful to start from the basics. So this is giving you the entire folder structure. It is pre-creating a lot of code for you. But in order for you to understand, what we have done is we have built something very handy that we call recipes. Okay, so now recipes is just like your recipes for cooking. So we have a bunch of very simple things that you can do to build a complex architecture, right? So in a very similar way, we start right from hello world, because of course, every programming language that you learn, it starts with a hello world component, which is the simplest component. So we have code snippets for each of these recipes, which show you how you can build this particular recipe. Okay, and using this recipe, what you will internally know is, let's say for a given functionality, how is it that I have to implement? And we have a bunch of different recipes, and all of it is again open source. So if you can look at the output, and if you want to view the source code behind it, you can click view source, and you'll be taken right to the source code on how this is implemented.
Or it will take it to the Git repository where the source code is.
Oh. Correct. So now what I'm going to do is I'm going to use this recipes as a baseline in order to explain to you what all the Lightning Web Component Framework is giving me. Okay, so what I have done is I have downloaded the entire GitHub repo. Okay, and it is the same structure. You have SRC modules.
I love this way of learning, Aditya, where we have a set of samples, examples, which does some simple use case, and then from there we can easily understand how the things work in the framework.
Understand, and if you want, you can copy paste.
Yeah, the most interesting thing for the developers, or do it simply.
Yes, and we've made it even more simple. So if you look at this recipe, let's say hello, and I have a title that says hello. So in my repository, what I need to look for is a module named hello. So it's that simple. Okay, so that you can easily correlate to which functionality is built using which module, or else it becomes a headache for developers, right? So now let me quickly go to SRC modules, and then here we have a bunch of different folders that I spoke about. Okay, so in this I have different UI folders. This is the namespacing that I was talking about. So in here I've created one folder called as recipe, so that all my recipes are bundled together, in which I have this hello folder. So just like the basic web component that I described, it contains a folder with the name hello, and it contains a HTML file and JS file. Okay, now let me go to the JS file first. So what you're looking at here is a very basic syntax for a JavaScript file. So if you remember from the very beginning of my demo, whenever I created a custom element, I defined a class that tells me what is the functionality of the custom element. It is the same standard here. And what I'm also doing is I'm exporting this so that it is available across. And this class extends lightning element, which is a wrapper we created on top of the HTML element. And this lightning element is something that is imported from the LWC bundle. So these two lines are basic for any web component that you want to create.
Oh, so it's basically like we are importing the lightning element from the LWC framework as a library.
Correct.
Yeah.
And then within my class, I have defined a simple variable called greeting, and I'm calling it world. So that's it. That is a very basic JavaScript that I have written.
Okay. So this is the property of the class which you are initializing to world.
Correct.
Okay.
Now, how do I use this property in the HTML file? So one of the advantages of the framework is data binding. So I can create my HTML file, and I created a JavaScript file with the same name, and I can bind those two together. So the framework does that job for me. So now if I go to my HTML file, the first thing you will notice is the template tag. So this is again a web standard that I've been talking about. So anything placed between the template is reusable. And I have defined some components. We'll get into that a bit later. But if you look at this particular line in line number 4, I say hello, and then I say greeting, which is placed within curly braces. So what I'm doing here is I'm binding the property in JavaScript to the HTML file. So this is how simple binding takes place.
So basically in our very first demo, you were showing a template within the HTML body. So now this is separated into a separate file where it has only the components code within it.
Correct. So if you notice, I'm only defining the template, and I'm defining what should be the functionality of the template. I'm not taking care of creating the shadow DOM. I'm not reading the template and adding it to the DOM. All of it is taken care by the framework.
Taken care of.
Yes. Now let's go a bit deeper. So the next one, hello binding. Here you see that there is an output text called hello world, and then this is a text box. So the moment I change the value in this text box, my value is automatically changing in the UI as well. So it's like automatically refreshing, right? So how did I implement this? So again, let's take a look at the code. So let me close these two and now go to hello binding. So in hello binding, this is the same JavaScript file again, the same import statements, the same export statements. But what you'll notice is other than just a lightning element, I have also imported something called as track. And to my greeting property, I have decorated it with track. That means I have put @track. So like I mentioned about decorators, it enhances the functionality of a given property. So the primary purpose of track is to make this property reactive. What it really means is the moment the value of this property changes, because I have decorated it with track, the UI is automatically refreshed. So that is taken care by the framework again. And I have defined a simple handle change event because that is again HTML standard. You have an input box. Anytime the value changes, it fires a handle change event. And in that handle change event, I'm actually updating this property's value.
Okay, so basically from HTML, if you want to send something to the JavaScript, then you are using DOM events there.
Correct.
And then handling it here. And whenever you want to send some information from your JavaScript to the HTML, you're using a decorator called @track. Is it a specific implementation for the Lightning Web Component Framework?
Yes.
Okay.
So anything imported from LWC is a specific implementation. I have one more decorator that I'm going to show you.
Yeah.
But yeah, so the hello binding HTML in turn again is not very different. It just contains the same greeting and the input. But because this greeting has been decorated with track, automatically this gets refreshed whenever the value changes. So that is the benefit. Now, the next one is in any programming language, you learn variables and then you learn conditional statements and looping statements.
Yes.
So we look at conditional rendering. Okay, you've been used to doing conditional rendering either using jQuery, using hide and show, or with plain old JavaScript saying document.getElementById.style.display is equal to none. So that's a lot of work to do, right? And that is not how you would do a single page application. So here, with this templates, there is one advantage that you get. So let's go to this hello conditional rendering. And what you'll see here is again another property, which is a Boolean property that is initialized to false, which we are saying essentially show some section or not. again @track, which means anytime this value changes, the hide and show thing, depending on whatever the value is, automatically gets refreshed. Now, if you go to the HTML file, what you will see is the primary template tag, but whatever is the conditional statement that you want to show, you place it within another template tag and you add a directive. So directive is nothing but another kind of attribute that defines the functionality of this element.
So basically, we are using this kind of conditional statements not in the JavaScript language. Rather, we are doing something on the markup side within the HTML as a directive, is it?
Yes. So I define a template and I say if true, and I bind it to the property in JavaScript. So whenever this value is true, this section shows up. And very similarly, I have if false. So whenever the value is false, this section shows up. So whenever I want to hide and show each of these sections, I just need to update this property value. And because it is tagged, these sections re-render automatically.
This is one interesting thing I was looking for as a web developer.
I would call it elegant.
Some conditions, yeah, so that we can check the conditions in the markup itself and then do the stuff there.
Correct. And let's look at, because we have seen the conditional statement, we'll look at how you can iterate. So iteration, again, you have another recipe called as hello for each. And the output for that is, let's say you have multiple records that you want to show in a list. So this is the output for that. And the code behind it is again very simple. Again, it is the same template tag, but this time we have a different directive. We have for each, which takes in an array, and for item is the individual element in that array, just like a similar for loop in other programming languages. Yes. You have a list and you have an iterable value. So you can use that within the template to do whatever you want.
That's awesome. That's awesome. So basically, we can process a array of stuff which is coming from the JavaScript, like array of objects or array of variables, which we can process through in this iteration and then render it accordingly. Is it?
Correct. So you'll see you are not doing a lot of code for this. You're just writing like 3 lines in here, and let's say depending on your logic, you are defining an array in your JavaScript. So all the recipes, the way we have structured is that it is very easy to learn. It's primarily almost all the times within 30 lines of code.
That's interesting.
Yeah. So, I mean, there are complex functionalities, of course, but yeah, most of the times it is 30 lines of code or less.
Yeah, that indicates that we can write the functionality in less number of lines using the Lightning Web Components framework.
Maintainable is what is one advantage you get with this.
It is easily maintainable. Yeah.
Now, the next example is sort of embedded into all of the examples I have shown you. So I have shown you all of these recipes, and you'll see that in all of the recipes, the code was only until when we looked at hello world component. The code was only until hello world. But where did this bind the HTML element to a property and view source and all come from? So this is where I embedded another recipe into my code. So what I've done is I've embedded another web component into my web component. So the way this works is again very simple. So you have all these different web components that you have created. And now if you want to embed a component, of course, the first thing that you write is what folder it is in. So in this case, I'm embedding something in the recipe folder.
So it's like a namespace which we are giving. So correct. Folder is like a namespace for us.
Correct. And then you have view source. So you can look for the view source web component. And what you'll notice is view source is actually put in camel case here.
Yeah, and I can see it's 2 words.
Yeah, it is view and S is capital.
Yeah.
Now the way you use it when you want to embed it is you split the word wherever there is a capital letter. So we call this the kebab case.
Okay.
So you say recipe hyphen view hyphen source.
So basically when we define the component, we define it in camel case, and whenever we are using it as a markup within our HTML, then we are going to use it in a kebab case.
Yes, this is important. And in case you don't use it this way, during compile time, obviously our platform knows, our framework knows that it is not able to find this component. So it says I'm unable to find this component. So it means either you have not created the component correctly or you have not named it correctly. Okay, now you'll notice that my recipe view source is also taking in parameters.
Yes.
Right, so I'm including some dynamic nature to this. I'm saying this is a text that is written within. So let's say
so it's just like any other standard HTML element which takes the parameters.
Correct. So within, I'm passing this value, loop through an array items in a template, and I'm also having a link here. So here, if you notice, I'm passing this value from within the parent component. And then I have a source which I'm passing as again as a parameter. which is the hyperlink. Now, how have we defined this? So now the HTML is of course very simple. You know, we are just showing whatever we have synced. We have used a slot here.
Yeah.
And if you remember from the initial example, whatever you pass in as a dynamic parameter, it comes into the slot.
Yeah.
Dynamic value, that is.
So that's where I could see, like when we came to this particular code sample, in slot we are given footer there. So your element is going to be rendered as a footer part of your component, is it?
Correct, correct.
Cool.
And that is my code, yes. So this is the one that goes into the slot.
Yeah.
But and we are defining what slot it is. But what about this additional parameter? Okay, so now if I go to the JavaScript file, you'll see that there is a property called source.
Okay.
And what you'll notice is I have put a new decorator here called @API, and I have imported it from the LWC bundle. So the purpose of @API is I'm making this property public. That means if I wouldn't have put it with @API, I wouldn't have been able to pass source as a parameter value. But because I have done this, I'm exposing this property to public, so whoever is using my component can pass in values directly to this property, and it is bound. So if I say source is equal to, my code knows that it is binding to this same value of the JavaScript property.
Okay. So this dynamic binding, and the source value changes because it's a public property.
Correct.
Does it behave like a track?
Exactly the same.
Okay,
So
cool.
track and API work the same, except that API makes this property public.
Public. Okay, got it.
Yeah. So at a very high level, I think this is how the framework works. Okay, there are more complex examples. So I'm still in the basic tab.
Yeah.
Okay, there are events on how you can communicate from a child to parent, parent to child. And then what if you want to make a call out to a third-party API? So let's say if you want to search for books, I'm using Google API for that. And I click search, I get the values. So what really I'm doing here is I'm using the fetch API, which is again a part of the standard.
So this example demonstrates how we can call a outside API and show the results within the component.
Correct. Again, it's within 30 lines of code.
That's awesome. That's awesome.
Fetch API itself is very simple if you ask me. So it takes a very less number of lines of code. Now the next logical step is what if you want to embed third-party libraries? Let's say if you want to show a chart in your Lightning Web component, or you want to use D3 for these fancy charts. There are code samples for that as well. So I would encourage you and everyone listening to us to actually dive into these recipes to see how things are built. And of course, all the way you have the developer guide, that is the entire set of documentation available to you, which actually detail out everything in a theoretical way,
right,
including the component lifecycle, that is.
Yeah, and all those examples look really simple. Like now I can go through each of these headings, like as you have completed, I believe you have just done all the examples of the Hello tab. So if I want to look into more complex examples, then I can just go there, dig into it, and then copy paste that sample and see how it works.
Yeah,
that's all fine. But if I want to learn more about Lightning Web Components, so what should be my way to go, Aditya?
So it's these two simple links. We have been using it all along. LWC.dev is your one-stop shop for installation instructions and documentation.
Yeah.
And recipes.lwc.dev is to see how things are working in a live environment. So these are two sort of things that I would recommend that you go through. So given the time, I covered only as much as I could, but if you go to the documentation, you'll actually know what else the Lightning Web Component framework is capable of.
That's awesome. That's awesome. For those who are watching this webinar, you can also see on the right side pane, we have shared the links with you. You can click those links to go to lwc.dev and see what's in there. And you can also follow us on LinkedIn profiles as well if you want more information about LWC components. And with that said, I think it is the time for Q&A, Aditya. Are we ready?
Yes, let's take a look at the questions that have come to us from the questions panel.
Okay, so there's the question called, well, say here in LWC module, is it similar to the module Node.js modules?
Modules as such, we are using the standard modules. So if you are using export, import, it's the same.
Yeah, for those, I can also add a few points to it. Like, so when we are talking about the modules, we are talking about the ECMAS6 standard, where they have defined the modules concept within the JavaScript, where we can write the functions as modules and then export those modules to be used by other JavaScript developers in their programs.
Correct.
So we have another question here, Aditya. Can we use arrow function also in IE11 inside LWC?
So arrow functions is again latest ES6 plus standard. So if IE11 supports it, yes, but like I've mentioned, the LWC framework sort of transpiles your code down to ES5 wherever necessary. So the framework should be taken care of. Framework will take care of it.
So we have a question. Is the unit case testing mandatory when we are building these components?
It is a best practice. So we don't enforce you to do anything. I mean, we can't. But if you're building some code, you want it to be production ready, and any changes you make, how you as a developer know that you haven't broken things developed by others, or how do you deliver that confidence to the client? So that is where these unit tests come into picture. So it is highly, highly recommended that you write unit tests for all of your codes.
Can you put some light on any differences between how we work on LWC components for the Salesforce platform and how do we do it on the open source framework?
Okay, so that's a good question. So like I mentioned, it is a framework as such that we have open sourced, right? So everything that I just described, the way you define a template, the way you use these decorators, all of that is exactly the same on Salesforce platform as well. But when you build using this framework on the platform, we add all the Salesforce functionality to it as modules. So you will be able to easily interact with Salesforce data. You'll be able to interact with the data model, and there is much more you can do on the Salesforce platform. But for open source, since we want this to be deployed across any platform with any backend of your choice, we've rolled out the framework, and you can feel free to write code to interact with any database. So let's say you want to integrate with MySQL. So you can write code for that using whatever framework it is and deploy LWC as a front-end framework for that. So there are some primary differences for Salesforce web components and the open source version, but it's nothing to do with the capabilities of the framework as such. It is to do with how tightly it integrates with Salesforce.
Yeah. And there's one question, any specific reason why we want to use the kebab case? So I would like to answer that. So that is the HTML web standard. So whatever elements you render within your HTML page, when you use it in the kebab case format. So that is the reason. Now we are sticking whatever we are writing, wherever we are using, we are sticking to the web standards there. So we are using kebab case to use it in our HTML pages.
Thanks, Satya.
So one more question about licensing. So, someone was asking about what kind of licensing is involved in the LWC open source. So it is the most flexible license.
MIT?
Yeah, I think it's MIT license. So which gives I think this is the most flexible open source license where you can you can get the source code from outside world.
Yeah, Jerry is going to send in the link for the license in the chat window. You can take a look at it. But yes, like we mentioned, the LWC framework is enterprise ready and it is production ready as well. So you can use it for whatever purposes you'll feel fit.
Why are you calling LWC as a framework?
Okay, that's a fantastic question. So here there is two different terminology that comes into effect. Okay, so Lightning Web Components with L, W, and C in capital letters, it denotes the framework. Okay, so Lightning Web Components is a framework, but the actual component that you build with it, we call it as Lightning Web Components itself. But the W and C for Web Components is small. Okay, but yeah, LWC, if you really want to refer to it, depending on how the capital letters are put in, it can be either a framework or a component built using the framework. Yes, thank you for asking that question.
Yeah, we have one more question here. Where is body a function of code? So that's where it's properly modularized. We have the HTML file, we have JavaScript file. So all the markup goes to the HTML file.
That is a
And
template
whatever,
tag.
yeah, and whatever functionality you want to write, that goes into your JavaScript file there.
So quickly to expand on that, if you go to the My App, you'll see that all of my modules are actually placed within the template tag. So let's take app.html, it is within the template tag. But the index.html, that was my entry point, was a HTML file with the body tag. And then the module as such is going to be placed within the body.
Okay.
So yes.
Yeah, and I have one interesting question. Track and API decorator work two-way binding like Angular or one-way binding like React? So this is really an interesting question, and I think this should be our one of the best questions, and it should be last question, I believe, because we are almost running out of time. But yeah, here it's all one-way binding because that is the standard. So track, whenever there's a change in the property which is decorated with a track, that property value is propagated to the markup, and you can see the value there. But again, if you want to get something from the markup, in that case, you'll have to use the DOM elements.
Or change events for that matter.
Yeah, any kind of DOM events there.
So yes, with that, we sort of wrap up the Q&A because we are almost out of time. And if we were not able to answer your questions, feel free to reach out to us on our social media handles that Jerry has shared in the panel.
Yeah, and we also will also be sharing a survey link with you after the webinar, so you can answer just feel free to fill in the survey, so that we'll get a better insight on how we can improve all our future webinars as well. And yeah, with that said, you have anything to say more, Aditya?
Thank you for joining us today.
That's an important thing we have to do. Thank you so much, everyone joined this webinar today.
Bye-bye.